important question. Let V be the vector space of all real polynomials of degree less than equal to 3 together with the zero polynomial over R, and let W1 and W2 be the subspaces generated by S1 these polynomials and S2 the another set of polynomials respectively. We have to show that the dimension of the sum of the subspaces is equal to 3 and dimension of their intersection is equal to 1, right? So here it is given to us that V is a vector space of all real polynomials of degree less than equal to 3. So what are the standard bases for this? It is x cube, x square, x and 1. These are the standard bases, and W1 is generated by the set of polynomials S1, right? So first we need to find out the dimension of W1, then we need to find out the dimension of W2, and then when we know these three dimensions, then we can find the dimension of their intersection by using the formula, that is dimension of sum of the subspaces is equal to dimension of W1 plus dimension of W2 minus dimension of their intersection. Okay, let's start with the solution. Now the standard basis be to be taken as x cube, x square, x1, because we are having the vector space of all real polynomials of degree less than equal to 3, right? Okay, it is given to us that W1 is generated by these three polynomials, right? So let's write V1 to be as x cube plus 4x square minus x plus 3, and I'm taking V2 as x cube plus 5x square plus 5, and V3 is 3x cube plus 10x square minus 5x plus 5. Let's write down the coordinate vector of V1 relative to these bases B. Just writing the coordinates. The coordinate of x cube is 1, the coordinate of x square is 4, the coordinate of x is -1, and then it is the constant 3 dash, right? That is represented as a column matrix 1, 4, -1, 3. Similarly, we write the coordinate vector of V2 with respect to the relative basis B. So it is 1, 5, 0, 5 dash, and then the coordinate vector of V3 relative to the basis B is 3, 10, -5, 5 dash. To get the dimension of W1, we need to write these vectors in a matrix form. So let me write the elements in the first row to be as 1, 4, -1, 3. This is 1, 4, -1, 3. And then is 1, 5, 0, 5. So this is 1, 5, 0, 5. And then writing 3, 10, -5 and 5. Okay, let's reduce this matrix into an echelon form. So I'm already having 1 in the first row. And for the first column, I need to make other entries to be 0, so that this 1 becomes the leading element for the first row. Alright. To get 0 in place of 1, just multiplying the row 1 with -1 and adding its elements to the row 2. 1 multiplied with -1, we get -1, adding this to 1, we get 0. 4 multiplied with -1, we get -4, adding this to 5, we get 1. -1 multiplied with -1, we get 1, adding this to 0, we get 1. 3 multiplied with -1, we get -3, adding this to 5, we get 2. To get 0 in place of 3, just multiplying the row 1 with -3 and adding its elements to the row 3. So 1 is the leading element for the first row. I'm having 1 to be the leading entry for the second row. To get this to be the leading element for the second row, I need to make 4 and -2 as 0. To get 0 in place of 4, I need to multiply the row 2 with -4 and adding its elements to the row 1. Writing the second row as it is. To get 0 in place of -2, just multiply the row 2 with 2 and adding its elements to the row 3. So this is your echelon form matrix, and we are having the number of non-zero rows to be as 2. Writing the bases now. So I'm having in the first row 1, 0, minus 5, right? So this 1 becomes the coefficient of x cube. This is the coefficient of x square. This is the coefficient of x, and this is the constant, right? So the polynomial becomes x cube minus 5x minus 5. And then the another one, the coefficient of x cube is 0, so skipping x cube. Coefficient of x square is 1, so this is x square. Coefficient of x is 1, so this is plus x plus 2. So these two forms the basis for W1. And how many number of elements present in the basis? It is 2. So the dimension of W1 becomes 2. W2 is generated by these three polynomials. So let's take V4 to be as x cube plus 4x square plus 6, and V5 to be x cube plus 2x square minus x plus 5, and V6 to be 2x cube plus 2x square minus 3x plus 9. Writing the coordinate vectors of these vectors relative to the basis B. So coordinate vector of V4 is 1, 4, 0, 6 dash. Writing the coordinate vector of V5 with respect to the basis B, we get 1, 2, negative 1, 5 dash. And for V6 we are getting 2, 2, minus 3, 9 dash. Please remember, this means that this vector is in a column matrix, right? So writing all these vectors into the matrix form now. So already I have written this. So just changing this matrix into the echelon form first, right? I'm having 1 to be the leading entry for the first row. What is the leading entry? It is the first non-zero element of the row. To make this to be the leading element, we have to make all other entries to be 0 under this element, right? To get 0 in place of 1, just multiply the row 1 with negative 1 and adding its elements to the row 2. So this is 0, minus 2, minus 1, minus 1. To get 0 in place of 2, just multiply the row 1 with negative 2 and adding its elements to the row 3. So we are getting 0, negative 6, minus 3, minus 3. So this element becomes the leading element of the first row. We are having negative 2 to be the leading entry for the second row. So to make this as the leading element, I need to make all other entries to be 0. To get 0 in place of 4, just multiply the row 2 with 2 and adding its elements to the row 1. So I get 1, 0, negative 2, 4. Writing the second row as it is. To get 0 in place of negative 6, just multiply the row 2 with negative 3 and adding its elements to the row 3. So we are getting 0, 0, 0, 0, right? In the second row, I'm having all the negative signs. So let me apply one more operation, that multiplying the row 2 with negative 1. So I'm getting 0, 2, 1, 1. So this is your echelon matrix, and the number of non-zero rows are 2. So writing the basis of W2 now, I'm having 1, 0, negative 2, 4 in the first row. So the first element of the basis becomes, the coefficient for x cube is 1. So it is x cube. The coefficient of x square is 0. The coefficient of x is minus 2. So this is minus 2x. And then the constant 4. The other element becomes, the coefficient of x cube is 0. So skipping this, the coefficient of x square is 2. So this is 2x square. Then plus x plus 1, the constant. So these two forms the basis. So this is x cube minus 2x plus 4 and 2x square plus x plus 1. So this is the basis for W2. How many number of elements present in the basis? 2 elements, right? So the dimension of W2 is 2. Now to find the dimension of sum of the subspaces, right? Now since W1 is generated by these 3 vectors, W2 is generated by these other 3 vectors, then their sum is generated by all these 6 polynomials. V1, V2, V3, V4, V5, V6. So after getting the coordinate vectors of these vectors relative to the basis B, let's write all the elements in a matrix form. So I have already written all these in a matrix form. So let's get the echelon form from this matrix. I'm having 1 to be the leading entry for the first row, right? To make this to be the leading element, I need to get all other entries to be 0. So many operations needs to be applied now. To get 0 in place of 1, just multiply the row 1 with -1 and adding its elements to the row 2, right? Then, to get 0 in place of 3, we multiply the row 1 with -3 and adding its elements to the row 2. To get 0 in place of again this 1, we multiply the row 1 with -1 and adding its elements to the row 4. Similarly for the other two also. Writing the first row as it is, after applying the operation for the second row, the elements becomes 0, 1, 1, 2. For the third row, I get 0, -2, -2, -4. For the fourth row, I'm getting 0, 0, 1, 3. To get 0 in place of this 1, we multiply the row 1 with -1 and adding its elements to the row 5. And to get 0 in place of 2, we multiply the row 1 with -2 and adding its elements to the row 6. So I'm getting for the row 5 to be 0, -2, 0, 2. And for the row 6, I'm getting 0, -6, -1 and 3. So here 1 becomes the leading element for the first row. All other entries are 0. So it becomes now the leading element for the first row. For the second row, I'm having this 1 to be the leading entry. So I need to make all other entries to be 0, 0, 0. For that, to make this 4 to be 0, I need to multiply the elements of the row 2 with -4 and adding its elements to the row 1. So I'm getting in the row 1 to be as 1, 0, -5, -5. Writing the elements of the row 2 as it is. And then to get 0 in place of -2, I need to multiply the elements of the row 2 with 2 and adding its elements to the row 3. So I get the elements in the row 3 to be as now 0, 0, 0, 0. I'm already having 0 here, so writing the row 4 as it is, 0, 0, 1, 3. And then to get 0 in place of -2, just multiplying the elements of the row 2 with 2 and adding its elements to the row 5. So I get 0, 0, 2, 6. And to get 0 in place of -6, just multiply the row 2 with 6 and adding its elements to the last row. So I get 0, 0, 5 and 15. So now this becomes the leading element for the second row. The elements for this row is already 0. So let's move on to the next row. This one is the leading entry for the fourth row, right? To make this to be the leading element, I need to make all other entries to be 0. Alright, to get 0 in place of -5, just multiply the row 4 with 5 and adding its elements to the first row. To get 0 in place of 1, just multiply the row 4 with -1 and adding its elements to the row 2. Then, to get 0 in place of this 2, we multiply the row 4 with -2 and adding its elements to the fifth row. And at last, to get 0 in place of 5, I multiply the same row with -5 and adding its elements to the last row. So on applying all these operations, the row first is changed into 1, 0, 0, 10. Second row is changed into 0, 1, 0, -1. Third row is already a 0 row. Fourth row written to be as it is. Fifth row is changed into 0, 0, 0, 0. And sixth row is changed into 0, 0, 0, 0. So now this also becomes the leading element for the fourth row. I'm having the leading element for the first row. I'm having 1 to be the leading element for the second row. I'm having 1 to be the leading element for the fourth row, right? And all other rows are 0 rows. But if I replace this fourth row with this third row, I can have the leading element for the third row also, right? So let's interchange these rows. So I'm interchanging third row with the fourth row. So now this one becomes the leading element for the third row. And all other remaining rows are 0 rows. And we are having the number of non-zero rows to be 3. From the elements of these non-zero rows, let's write the basis for the sum of the subspaces. From the first row, 1 is the coefficient of x cube, 0 is the coefficient of x square, 0 is the coefficient of x, and 10 is constant. So writing the first polynomial as x cube plus 10, right? Similarly, from the elements of the second row, we get the polynomial to be as this is the coefficient of x square and this is constant. So it is x square minus 1. And from the third row, this is the coefficient of x and this is constant. So we are getting x plus 3. So this is the basis for sum of the subspaces. And how many number of elements present in the basis? Yes, 3 elements. So the dimension of sum of the spaces is 3, right? Okay, as we know that dimension of W1 plus W2 is equal to dimension of W1 plus dimension of W2 minus, we need to get the dimension of the intersection of the subspaces, right? Okay, dimension of sum of the subspaces is 3. Dimension of W1 is 2. And dimension of W2 is also 2. So this is 2 plus 2 minus, we need to find this. So taking this to the other side, we get the dimension of intersection of the subspaces to be equal to 2 plus 2 is 4, then minus 3, and that is equal to 1. So the dimension of the intersection of the subspaces is equal to 1. So this is shown. Alright, thank you.